A quote from Neil deGrasse Tyson: "The universe is not only bigger than we can imagine. Under most scales, it is bigger than we can imagine." Does the universe have an end and a beginning? Has the James Webb Space Telescope, JWST, finally discovered the edge of the observable universe? Since time immemorial, we have wanted to know how big the world we live in is. We meticulously search for boundaries and truths, and in doing so, our knowledge has continued to expand. In the past, the edge of the world was somewhere beyond the horizon. Today, we use telescopes to search the universe for clues that show us whether our universe is a finite space. We may now have achieved a decisive breakthrough in this elementary question with the James Webb Space Telescope. Whether the universe has an edge is not a question, it certainly has one. However, we do not know whether this edge is actually the end of the universe or of creation. An edge could also be like a threshold that leads into another universe or into previously unknown dimensions. Our Earth also has an edge, as do the solar system and the galaxy. Nevertheless, the cosmos does not end there. Neil deGrasse Tyson is absolutely right that the problem with the size of the universe is in our heads and not in the universe itself. The universe is bigger than we can imagine. We can only search for the beginning and end in the distance or in time, and we still use comparatively modest tools to do so. With our telescopes, we are currently looking about 46.5 billion light-years in every direction, which means we are looking at a total diameter of about 93 billion light-years. So far, there has been no end in sight, and the mass of stars, galaxies, and phenomena that we have found in this area is beyond imagination. It would take us thousands of years to explore and investigate every corner of the universe that we already know. Nevertheless, driven by an insatiable curiosity, we continue to look further and further. We want to know whether the universe has an edge and what it looks like, and the JWST should finally show us this edge. Does the universe have a beginning? A quote from Neil deGrasse Tyson: "The James Webb Space Telescope identifies objects in the darkness that, according to the best measurements we have, are large, fully developed galaxies. We humans are simple-minded. For us, everything has a beginning and an end. We usually think in terms of facts and figures as well as spatially limited and confined structures. However, anyone who deals with the universe soon comes up against the limits of thought and perception. In order to understand the incredible dimensions within the cosmos, most of us have to stretch the limits of our perception. The sheer size of what we see so far, the number of stars, the countless planets, and the strangest cosmic phenomena, pushes a narrow and limited mind to open up. In general, astronomers and cosmologists should therefore be among the most open-minded and free-spirited people, or so one would think. But our scientists these days have to realize that they too are still quite limited and that they may have been thinking within boundaries that prevented them from recognizing the truth of the universe. The JWST is now pushing our space researchers to their limits. Theories and truths are wobbling, and it's quite possible that our worldview will take another leap, as it did hundreds of years ago when people understood that the Earth is round and not flat. The James Webb shows us 6 galaxies that are so old and so perfectly developed that they should not actually exist in the epoch observed. The JWST was designed to look into the dark ages where the first stars were formed. But instead of showing us the expected protostars and baby galaxies, the telescope serves us rows and rows of perfectly formed and very old-looking galaxies. So, are we really looking at the beginning and thus the temporal edge of the universe? And above all, did the dark ages really exist, or did we humans just make it up because we didn't know the truth? The 6 galaxies are not the only shocking discoveries made by James Webb. The telescope also found a gigantic cluster of galaxies that existed too early for it to exist. In galaxy clusters, millions of galaxies come together in groups. Until now, we thought that individual stars were formed first, then star clusters, later galaxies, and then galaxy groups. What does a cluster of galaxies that existed at a time when the universe was supposedly still very young want to tell us? Countless galaxies with a redshift of greater than 10. A quote from Neil deGrasse Tyson: "The problem is not the universe. The problem is us because we think we know more than we actually do." It sounds crazy, but the JWST is still showing us more galaxies at a time long known as the dark ages of the universe. Almost all of the galaxies Webb found in the early universe have a redshift of more than 10, meaning they existed when the universe was 2% of its present age, that is, a few 100,000 years after the Big Bang. These discoveries do not show us a dark world but a universe that actually looked much the same as it does today. These discoveries are so incredible that scientists initially doubted Webb's findings. However, the spectroscopy of the telescope has confirmed every single result several times over. Spectroscopy played a crucial role in confirming the distance and properties of the extremely distant galaxies. Astronomers use this method to break down the light of an astronomical object into its different wavelengths and thus determine the age of the light source and physical properties such as its chemical composition. Webb's results showed that these galaxies are not only very old but also contained elements and a number of stars that do not fit with a young universe. The temporal edge of the universe is currently moving further and further away from us. But what about the spatial edge? Have we already found it, or can we find it? Here we come up against a paradox, because if we are looking for something in a space that exists now, we would have to see this space in real time. Imagine you are looking for the walls in a very large concert hall. It's dark except for a few small LED lights at a distance of 10 or 20 meters. You don't know exactly how big the room is, nor can you see the walls. You would have to personally search for the edges by feeling your way around. This option is not possible for us in the cosmos because we cannot travel through it personally at the moment. The other option is that you have a telescope with which you look further and further. You focus on the bright places, or, in other words, where the LEDs are, because you can see at least a little bit there. If your telescope is good enough, you might be able to spot the walls of the room at some point. But the tricky thing about the universe is that it's moving at the exact moment we are looking with our new super telescope, the JWST, as if the walls of space are expanding while you are looking. So you have to make sure that you keep up with the movement of the walls as you develop your telescope technology and range in space. We encounter another phenomenon that makes the search for the walls or an edge more difficult. Light takes time to travel through space. With the JWST, we see light that has traveled 4 light years, 100, 1000, or even 13 billion light years, so we only ever see the past. Strictly speaking, you also see the past in your room, but the light from LED 60 or 100 meters away only needs a fraction of a second to reach your eyes. So here we can say that you experience space in real time. But in the universe, the temporal dimensions are different. We can already see the nearest star, Alpha Centauri, as it was 4 years ago. Of course, we can say that the universe must have been even smaller 400,000 or 5 million years ago because it hasn't expanded that far yet. Nevertheless, we have not yet succeeded in finding any signs of a spatial limit. Instead, we have found evidence that the universe is not expanding at the same rate everywhere. This could mean that our cosmos does not have a uniform, homogeneous form but is structured in a way that we have not yet recognized. Have you ever thought that it might be a mistake to look for boundaries or a beginning? Perhaps this new era of space exploration wants to show us that we have to stop thinking in terms of limited dimensions in order to go beyond what we have considered to be true so far. In its own way, the JWST shows us again and again that there seem to be no limits even within the universe. Again, the telescope found structures that break boundaries, and it wasn't even about searching for an edge. James Webb took a look at a distant galaxy and found such a huge active galactic center that scientists were speechless. At the center of this young galaxy, only about 570 million years after the Big Bang, a quasar with a black hole 10 times the mass of our Sun was already raging. Black holes that are part of an active galactic nucleus emit an unusually large amount of light, which is produced by the friction of the material flowing into the black hole in a spiral. Such galactic centers shine trillions of times brighter than the brightest stars. Even in its search for exoplanets, the JWST is constantly showing us that we must stop thinking in terms of limits. We must strive for diversity and infinity if we really want to understand the universe. HIP 65426b was already identified by Hubble in 2017, but now, thanks to Webb's unique new capabilities and highly sensitive spectrometers, we have even clearer data from this distant world. HIP 65426b is a huge gas giant about 12 times larger than Jupiter. It's located at a distance from its star that is 100 times greater than the distance from the Earth to the Sun. That's more than twice as far as the dwarf planet Pluto is from the Sun. Using Webb's coronagraphs, cameras, and various filters, this planet has been imaged directly for the first time, which is an absolute exception as most exoplanets are discovered by transiting in front of their home star or by indirect methods. These are just 2 extremes and 2 more examples of the fact that we have to reckon with the idea that there are so many phenomena, peculiarities, exceptions, and ever-new dimensions to discover in the universe that it would be downright foolish to look for an end, edges, or limits. Subscribe to the channel now and be part of every new video highlight.